Here is question number 21. A column is filled with water as shown in figure. If liquid in the left limb is slightly depressed and released, then time period of oscillation will be, where L is the total length of water in column. Now we know very well the time period of oscillation of liquid in given tube is given by the expression T equals 2 pi under root L upon G times sine alpha plus sine beta, where alpha and beta are the angles from horizontal. So here we can say that alpha is 90 degree clearly and beta is 37 degree. Now let us putting these values into the expression. We'll get T equals 2 pi under root L upon G times sine 90, that is 1, plus sine 37, that is 3 by 5. So T equals 2 pi under root 5L divided by 8G. This is the final expression we will get, and if we find the option, we can say that option number 2 is absolutely correct. So we will go with option number 2 only. Now let us proceed to the next question, that is question number 22. So here is question number 22. A transverse wave propagating along x-axis is represented by y, function of x and time, is 0.8 sine pi by 4 minus 4 pi t minus pi by 2 x, where x is in meter and t is in second. What will be the velocity of wave? Now we know very well the expression can be given as y equals, taking the negative sign from here outside, we will get minus 0.8 sine 4 pi t plus pi by 2x minus pi by 4. So we have just got the standard form, that is y equals a sine omega t plus minus kx plus minus phi naught. If there it is minus of kx, it means the wave is propagating in positive x direction, but here it is plus kx, so that's why we can say that wave is traveling toward negative x direction. Now let us calculate the speed of wave. V can be written simply by omega upon k, where omega is this one, that is 4 pi, and k is pi by 2. So omega, that is 4 pi divided by pi by 2. After solving, we will get the speed of wave, that is 8 meter per second, traveling toward negative x direction. So we can say that option number 2 is absolutely correct, and we will go with option number 2 only. Now let us proceed to the next question, that is question number 23. So here is question number 23. 2 point charges 4 microcoulomb and minus 8 microcoulomb are placed at a distance of 1.5 meter. The total number of points except infinity where potential due to system of charges is 0. So suppose there is 4 microcoulomb charge right here, it is minus 8 microcoulomb. This is the line joining them. Suppose at this point the potential is getting 0. It means k q1 by, suppose the distances are r1 and r2 respectively, k q1 by r1 minus k q2 by r2 will be what? 0. This is the expression for total potential. Now after solving, we can write here k cancel out. So the ratio of r1 and r2 will be what? q1 upon q2, that is 1:2. Means for every point, for any point, if the ratio of r1 and r2 is getting 1:2, then at that point the potential will be 0. So we can say that since potential is a scalar quantity, and from the discussion we can say that potential will be 0 at all points having ratio R1 R2 1:2. So therefore we can say that infinite number of points. Infinite number of points. After looking the option, we can say that option number 4 is absolutely correct. So we will go with option number 4 only. Now let us proceed to the next question, that is question number 24. Here is question number 24. Charge capital Q is enclosed by a Gaussian surface. If surface area is doubled and charge Q is tripled, then the outward electric flux will be. According to Gauss theorem, we are knowing that the total flux bounded with the closed surface is equal to total charge enclosed divided by epsilon naught. Means it is simply depending upon total charge bounded with the surface. So if charge will change, then flux will also be changed. If charge is tripled, then flux will also be tripled. So here flux phi is directly proportional to Q enclosed. It means if Q enclosed is tripled, then flux also tripled. And we can say that option number 1 is absolutely correct. We will go with option number 1. Now let us proceed to the next question, that is question number 25. Here is question number 25. Series parallel combination of capacitance. We can see for a circuit as shown in figure, the equivalent capacitance between point A and B will be what? Now this question can be done by the simplest method. Point out the junctions. This is 1, this is 2, this is 3, this is 4. Just name them P, Q, R and S. This is point A, this is point B. Suppose now point A and point Q, if you see, both are same. They are connected directly with the wire, so they will be at same potential. So AQ will be same. Again point P, point R and point S, they are the same actually, because they are connected directly with the wire, so they will be at the same potential P, R and S. Now let us fit the capacitors. Between A and point P, we are having one capacitor. Here it is A, here it is P. Between point P and point Q, we are having one more capacitor. So point P is here, point Q is here, one more capacitor. Between point Q and point R, we are having again one capacitor. This is Q, this is R, one more capacitor. Point R and point S, they are at the same potential. There is no potential difference between them. So these two capacitors, they are useless right here. So they will be removed. Charge will not pass through them as there is no potential difference between them. Now between S and B, you are having two parallel capacitors. So they are C, 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 and here it is 2C, C. Solving C, C, C gets you 3C, 2C and C parallel gets you 3C. Point B, point A. After solving 3C, 3C, they are in series. The combination of them will be CAB. That is 3 by 2 times C. And after looking the option, we can say that option number 4 is absolutely correct. We will go with option number 4. Now let us proceed to the next question.